Hello, good afternoon. This is Sharad Jain, Assistant Professor from EC Department, IPS Academy. Today we will learn about half-wave rectifier, how the half-wave rectifier works. So, in the previous class, we came to know what's a rectifier. So let's have some recap about the rectifier. A rectifier is a device which converts your AC into DC. Means it converts alternating current into direct currents. So in rectifier, the main component is diode. So sometimes diode is also known as rectifier. So let us begin. There are three types of rectifiers. Mainly we can say there are two types of rectifier, that is half wave rectifier and full wave rectifier. So full wave rectifier are of two types, that is center tapped full wave rectifier and bridge type full wave rectifier. So today we'll see how the half wave rectifier works. This is the circuit. This is the circuit of half wave rectifier. You can see here is the AC source. This is the source voltage. Input is in AC. This one is the diode, and the load resistance is connected in series with the diode. So only few components are required for construction of half wave rectifier. One source is there, AC source. One diode is there and load resistance is there. This is the circuit diagram, simple half wave rectifier circuit. We know the source is of alternating nature, so it has two cycles, that is positive half cycle and negative half cycle. You can see from here, this is the source voltage, this is the positive half cycle, this is the negative half cycle. So it changes its polarity in after every half cycle. So during this positive half cycle, what happens, we'll see. During the positive half cycles, this end will be positive and this will be negative. During this, the diode will be forward biased and will start to conduct. When the diode start to conduct, the current will flow through the load, the source. So we can say we obtain the current will flow in the circuit, so we can get the output voltage across the load resistance. The current which flows through the circuit is Vs upon RL, with it I is equal to V upon R. Okay. During the negative half cycle, this end become to be negative and this end become to be positive. Under this condition, the diode becomes to be reverse bias, as anode is connected to the negative and cathode is connected to the positive end. So diode is reverse bias condition, it doesn't conduct. So no current will be flow. In this condition, the diode will be act as an open circuit. So since there is no current in the circuit, so we will get the no output voltage. So during positive half cycle, the diode conduct, it acts as a closed switch, it works, it acts as a short circuit, its resistance is very small and the current flows through the circuit, we get the output voltage from load resistance. During negative half cycle, the diode does not conduct, it becomes to be open circuited, no current flow and we don't get any output at the load. We can see the help of waveforms like that one. This is the positive half cycle, this is the source voltage, this is AC voltage which we are applying here. Okay, so this is the positive half cycle, negative, positive, negative. So positive half cycles are indicated by pink shaded cycles. Okay, this is the source voltage Vs, maximum value of the source voltage is the Vm. During the positive half cycle, you can see here from here, the diode will conduct. Diode will conduct means that will be a close path, short circuit is there, so current will flow, so we get the output at the load, we get the output exactly in the same whatever the input is there, so we get the same cycle at the output. However, its magnitude is somewhat lower than the input because of resistance. Okay. During the negative half cycle, the diode will be reverse biased, no current will flow, no output voltage will be obtained. In this manner this process repeats, so we get the output for the positive half cycle, we don't get any output for negative half cycle, and subsequently we can see from, so current flows from 0 to t by 2, no current will flow from t by 2 to t, and so on. So we can see we are getting the output voltage which is not for the full input cycle, we are getting the output only for half a cycle. So this is why it's called half wave rectifier, means the rectifier which rectify the input for only half wave. We can say from this diagram, this is the positive half cycle output, this is the positive half cycle output, this is the positive half cycle. If you want to get some average voltage, so the average voltage will be like that, this one is this, because we are getting the output here, we are not getting output here, so the average output voltage, it is called V average, it is somewhat lower than the peak value. So we can say there are ripples, means some AC components are there in the output, that's why we are getting the lower average output voltage. However, in order to improve, means to reduce the ripples in the output voltage, we use the filter. So here we are using the capacitor filter. During the positive half cycle, when the diode conducts, the capacitor charges to its peak value. However, when the negative cycle come here, this capacitor will discharge only through this path, load resistance. So this is the scene when the capacitor charge during the positive half cycle, it will charge up to maximum value of the input peak voltage. During the negative half cycle, the diode will be open circuited, the capacitor will discharge through this load resistance, we get the outputs. So in the next positive half cycle, the capacitor starts to charge again, it will start to begin charge again. In the negative half cycle, it will, means for the positive half cycle it store the charge, and for the negative half cycle it will deliver the output voltage, so load. So we can see from here the capacitor will start charging, it will charge to peak value. So after charging the peak capacitor to peak value, the capacitor will start to discharge through the load. When the capacitor charges very slowly, and when it goes some particular value, the positive half cycle comes again and it will start to charge again, and this process. So we can say using the capacitor filter, we can reduce the contents, we can reduce the ripples in the output voltage. So instead of getting this and this one, we are getting this one. So we can say that we are getting the output that is smooth. However, the ripples are also there, but we are getting somewhat very lower content of the AC. So in the today's lecture, we learn that half wave rectifier converts your input cycle into rectified output voltage having some AC components. Thank you.